Welcome, everyone. Listen, I am absolutely thrilled to have you here for this explainer. Today, we're targeting a very specific and honestly an incredibly high-yield topic for the Cambridge IGCSE Additional Mathematics 0606 exam. If you're a focused learner looking to maximize your score and really figure out exactly what examiners are looking for behind the scenes, you are in the perfect place. We're going to be completely demystifying the topic of equate-like vectors. Now, I know vectors can sometimes feel like this giant confusing maze of arrows and abstract logic, but today we're breaking it down using a purely strategic slide-based approach. We're going to look at the theoretical foundations, the technical methodology, and some absolutely crucial examiner insights. So grab a pen, get comfortable, and let's dive right into this. 15. I want you to just look at that number for a second because it represents a massive, massive opportunity for you. Did you know that the equate-like vectors topic alone accounts for approximately 15% of the total marks in the additional mathematics examination? Yeah, 15%. That's roughly 1 in every 6 marks on your paper, just for this single conceptual area. Think about 2 typical students for a second. Let's call them Alex and Sam. Alex overloads their answers with raw math facts, but shows zero analysis. Sam just rushes through the paper and completely misses the actual requirements hidden in the command words. Both of them are practically throwing away this 15%. Mastering this one topic can literally be the difference between a passing grade and an absolute top-tier mark. Lock this down, and you are banking a significant portion of your final score before you even step foot in the exam hall. So, to make sure you capture that full 15%, here's our roadmap for today. First up, the 15% secret. Second, the method mark strategy. Third, we'll go through a systematic procedural framework. Fourth, we're looking at top examiner warnings. And finally, critical analysis and evaluation. Okay, let's jump into section 1, the 15% secret, and what examiners are actually trying to test.
To really beat the exam, you have to kind of get inside the mind of the examiner. The assessment objectives for equating like vectors aren't just about magically getting the right number at the end. They're actually targeting 3 completely distinct cognitive domains. First, there's knowledge and understanding. And look at the required action here. It isn't just mindlessly memorizing formulas. It's your ability to actively extract the relevant data from a really dense word problem. Second is application. You've got to take that extracted data and execute it using crystal clear mathematical notation. And third, analysis. This right here is where the top students totally shine. They actively question the assumptions within the problem itself. Are the vectors parallel? Are they collinear? You have to prove to the person grading your paper that you understand the underlying geometry, not just the basic algebra.
Moving right along to section 2, the method mark strategy, or how to score points just for your process. Okay, so the absolutely crucial takeaway here is this. The assessment framework prioritizes analytical depth over superficial breadth. What does that actually mean for you when you're sitting at that desk? It means the Cambridge academic benchmarks require logical, structured reasoning. Examiners award marks for the process. If you just jump to the end and write down a final answer, even if it's 100% correct, you might literally score a 0 if you haven't shown your analytical depth. Equating like vectors is essentially a process of setting your I components equal to each other and your J components equal to each other. Documenting that specific step on paper, physically showing that structured reasoning, is exactly how you secure those vital method marks. And before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's look at section 3, the systematic procedural framework. This is the standard sequence that top candidates use. Top scoring candidates don't just guess their way through an exam paper, right? They don't just hope for the best. They use a highly standardized 4-step blueprint. Step 1. Deconstruct the question and extract the data. Find those key elements hiding in the text. Step 2. Select the analytical framework. Ask yourself, okay, which specific vector principles actually apply to this scenario? Step 3. Execute with clear notation. This means taking the time to use proper vector underlines, bolding, or setting up your column vector formats, whatever the question specifically demands. And Step 4. Verify your results and present your formatting clearly. Don't just wipe your hands clean when you find X and Y. You've got to verify them. To really cement this blueprint, we use something called the deconstruct, solve, evaluate loop. Think of this as the beating heart of problem solving when you're equating like vectors. It's an active, continuous feedback loop. You identify the given info, you break it into logical steps, solve it systematically, and here is the real kicker. You check for reasonableness. If you calculate a vector that implies a physical impossibility based on the context of the question, well, this evaluation stage is exactly where you catch your own mistake before the examiner with the red pen does. Oh, and stop scrolling for just a second. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCU and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's get into Section 4, Top Examiner Warnings. These are the common pitfalls you absolutely need to avoid. So we have literally scoured the actual Cambridge Principal Examiner reports to figure out exactly where students are bleeding marks on this topic. Let's rapid-fire the top 3 fatal mistakes so you can dodge them. First up, answers are often way too vague. When examiners ask for an explanation of a vector relationship, they want specific mathematical details, no general, wishy-washy statements. Second, candidates constantly forget to check format and presentation. If a question specifically asks for a column vector and you write down a coordinate, boom, you lose marks. Third, answers are not specific to the context given. Like, if the vectors represent velocity in a wind current, your final answer in your evaluation must relate back to that specific real-world wind context. Look at the stark contrast on this slide. Remember our hypothetical students Alex and Sam from earlier? When they rush or just dump facts on the page, they are using the vague approach on the left, skipping steps, showing poor presentation, and completely ignoring the context. That is the hallmark of a rushed candidate who is leaving easy method marks on the table. Instead, you want to be the student on the right. Examiners are practically begging you to adopt the precise approach, using clear terminology, showing systematic working out, and staying hyper-focused on the context. Whenever you do a practice paper, you need to actively train yourself to be this precise student. I really want to draw your attention to this quote right here. This is direct from the source material. Examiner alert. Candidates consistently confuse key terminology. Always define terms before using them in extended responses. Guys, this is a massive red flag straight from the people holding the red pens. When dealing with equate-like vectors, practical application is what develops professional skills. If you have to explain why 2 vectors are equal, or why equating their components solves the problem, do not just guess the words. Use the correct mathematical terminology and define it clearly. Finally, we've made it to Section 5, Critical Analysis and Evaluation, using evaluative thinking for absolute mastery. The top-scoring candidates, the ones getting the A stars, demonstrate evaluative thinking by questioning the assumptions made in the problem. They consider different perspectives and alternative interpretations. For example, they might ask, could this vector equation yield 2 mathematically valid answers, but only one that makes sense in the real-world context? They justify every single decision with solid, undeniable mathematical evidence from their working. And finally, they identify limitations in the data. Evaluating the quality of your evidence and double-checking your mathematical assumptions is exactly what pushes you from an average score right into the highest possible grade boundary. And hey, students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly explainers. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you back. So I want to leave you with this final, provocative thought. The very next time you sit down to do a practice paper on equate-like vectors, I want you to ask yourself, are you just calculating vectors, or are you actively proving your analytical depth to the examiner? Remember, it's not just about finding the numbers, it's about showcasing your systematic processing, your clear notation, and your logical evaluation. Master the process, avoid those vague, rushed answers, and that 15% is absolutely yours for the taking. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing right now. Our team responds to every single comment. Like and share this explainer with a study partner. Ace the Exams. Your Cambridge success starts here. Keep practicing that precise approach, and I'll catch you next time.